Everyone, I'm Nick Nellis, software engineer at Tetrate. I'm also an Istio contributor, and I do a lot of Istio support in Slack and discuss that Istio. And today I'm here with Adam Toy from Rancher Federal. We're both currently contractors for the Department of Defense and working on their Platform One initiative, and we'll talk about that in a little bit. And we're going to go through some of the debugging that you can do now with Istio. Over the last year, a lot of support has been added, and so we're gonna talk about that and do a pretty cool demo for you. So over the last year or two, we've seen a pretty big shift in the consumer expectations of Istio. 2 years ago, companies that were trying Istio were largely ahead of the curve, and they had different expectations of Istio. They knew they might have to hack on it a little bit to get it to work in their environment. But now shifting to 2021, we're seeing Istio a much more mainstream product. And so the expectations have shifted to Istio being more reliable, more maintainable, and easier to use. And you can really see from the highlights of 2020 that that's reflected of the maturity of Istio. A lot of work has gone into this lifecycle management, debugging, and just general adoption easiness. And so I'm going to hand it over to Adam to kind of talk about Platform One and then get started with his demo.
Awesome. Thanks, Nick. So like Nick said, my name is Adam Toy. I'm a solutions engineer at Rancher Government. I have been working with the Department of Defense and the intelligence community for around the past 7 years. Mostly I've been helping them with their digital modernization and their transition over to Kubernetes. I've been using Istio pretty extensively for a year plus now, and when I'm not doing Rancher-related things, I also serve as a technical lead for mission application deployments on the Air Force's Platform One program. So before we jump into the troubleshooting, I do want to take a little bit of time and talk about some of the awesome stuff going on at the DoD, specifically at Platform One. So Platform One, for those of you who don't know, it's both a platform and software as a service offering from the United States Air Force. If you've ever worked in the federal space, you know very well that getting your software to a point that it's authorized to operate or ATO'd is this very long, drawn-out process. There's just a lot of security controls and constraints that pretty much every application needs to adhere to before it's approved to go into those production environments. And even though we're deploying to satellites and fighter jets, we know that our technical challenges aren't unique to us. And I'm sure most of you have run into very similar challenges in the environments that you're working with. So what Platform One has done, they've actually compiled a number of cloud-based DevSecOps build tools, including CI/CD pipelines, real-time monitoring, log aggregation, and even a zero-trust infrastructure that provides a secure environment that can be inherited by all of these mission application teams to enable them to deliver code much faster and more consistently than they ever have before. At a very high level, it basically offloads a lot of that initial heavy lifting so they can focus on their specific use case. So one of the key elements of Platform One is known as Big Bang. So what Big Bang is, it's a fully free and open declarative continuous delivery tool for deploying core DoD hardened and approved packages into a Kubernetes environment. And just for context, when I say hardened, what I mean is these images are actually built off of other hardened and approved base images, and then they themselves are ran through the Platform One DevSecOps build pipeline, known as Iron Bank, just to ensure that it meets our established security standards. In addition to that, Big Bang is completely agnostic to Kubernetes distributions. One of Big Bang's major goals is to make sure that it works across all of the major distros. It also buys very heavily into the GitOps approach of managing all of your Kubernetes resources. And at this point, we all should be. Big Bang itself is backed by Flux, which if you don't know, it's a GitOps engine, but it also does support deploying Argo CD if that's your preference for managing your downstream applications. So what you're seeing here, this is just one implementation of the Big Bang. This is what we're using internally at Platform One for supporting mission applications. And this is what we call Party Bus. I do want to point out that this is in no way comprehensive of all of Big Bang's capabilities, and things are getting added constantly. So I would highly recommend that you check out the Git repository and the Getting Started guide. Both of those are at the top of this slide, and you'll see them at the end of the presentation. But just to walk through, we are using a lot of the Istio core components. So we're using ingress gateways for ingress into our cluster. And then we also deploy virtual services at the application namespace level for that fine-grained routing to specific workloads depending on application requirements. And just to establish that zero trust model that I was referring to before, we also deploy Istio authorization policies as well as Kubernetes network policies to, for the most part, only allow inner namespace traffic. For us, the applications that we manage, for the most part, are scoped at the namespace level, and they usually only need to talk to other workloads in the same namespace. If there are exceptions to that, for instance, a centralized auth service, MinIO, or maybe a common API that exists in some other namespace, we'll take a more customized approach to those auth policies and network policies, but we still analyze them to make sure that only the traffic that should be getting through is getting through. Also, Big Bang out of the box provides an entire monitoring stack for you. That includes your Prometheus, Grafana, Kiali, and Jaeger. In addition to that, it also provides log aggregation with EFK or Elastic Fluidbit in Kibana. And that's just great for aggregating all of your pod logs and then being able to do analysis on those logs later. Another really cool thing that we're doing is we're offloading the need for application teams and, more importantly, application code to implement authentication and authorization. What we're doing, we're implementing an Auth-Z envoy filter with a tool called Auth service, which we'll talk about a little bit later in demo. But basically what it's doing, it's offloading all of the JOT validation as well as doing the redirects to our centralized SSO. For us, our entire cluster is deployed onto AWS. That includes GovCloud as well as the classified environments. But we like to enable our application teams to use some of the other AWS resources like RDS and S3. And we want those to appear as part of our mesh. So we also define service entries just so Istio can properly manage the traffic and protocols to and from those. So like I said, Big Bang is an awesome tool. It's completely free and open. It can basically get you up and running with an entire secure DevSecOps build platform with hopefully minimal effort from you. So I would highly recommend you check it out. But we are here to talk about troubleshooting Istio, so let's go ahead and get into it. Just to help us walk through things, we did develop a very simple demo application. And what you're seeing here is just a very high-level overview of how the workflow should work for this application. Just to walk through that, so when a user makes a request, if they haven't logged into SSO before or their token is invalid or expired, they should automatically be redirected to Keycloak, which is that centralized SSO OIDC provider that we use. When they log into Keycloak, their valid auth token should be set as a JOT header in that request, and then they should be redirected back to the application. And now that they are authenticated, their browser should be able to get to both the UI and the backend API, and that should serve up a nice welcome message, as well as detailing the user's location and wishing them well. One other note that the backend API is actually going to use that JOT authentication token from Keycloak, extract the user's ID from it, and then use that to pull the user's location from a MongoDB backend. And since this is IstioCon, here's a high-level breakdown of all the Kubernetes and Istio components we're using. We're going to kind of use this as a basis of understanding as we're walking through the application. Also, I do eat my own dog food, so this entire application is deployed into a K3s cluster running on my home lab, and it's also deployed on top of Big Bang. Just to prove that, I'm going to go ahead and go over to my terminal. And like I said, Big Bang is deployed entirely on top of Flux, so I'm going to utilize the Flux CLI and just run Flux git helm releases in the Big Bang namespace. So you can see here, this is our entire Big Bang stack that is deployed into this cluster. And one other thing I do want to highlight is I'm going to do kgit deploy -n Istio system, and I'm going to do that wide. So you can see here, like I said, all of the images that are being deployed via Big Bang are these hardened images. They're all coming from registry1.dso.mil. These have all gone through that Iron Bank pipeline. They're all approved and secured. These aren't your Docker IO upstream images, which is really cool and really secure. One other thing I just want to go over, just so everyone has a basis of understanding, is just get all of the resources that we're using in this application. So I'm just going to do kgit all-n welcome map, which is the namespace that the application is being deployed to. So you can see here, it's very simplistic. It's pretty much 3 deployments, a UI, a backend, a Mongo database, and then Kubernetes services on top of that. There's also a few Istio resources on top of this that we'll talk about as we work through this. But let's go ahead and go to a browser and just see how our application is performing. So I'm going to navigate to welcome.istiocon.xyz and hit enter. So right off the bat, you can see I'm getting a 404 issue. an HTTP error. That's not ideal for any application. Generally speaking, when I'm working with Istio and I see a 404 error, the first thing I want to confirm is that this is in fact an issue internal to our cluster, whether it be Kubernetes, Istio, or the app code itself, and not something external. So a very quick and easy way to do that is to just pull up a JavaScript console. And I'm going to refresh the page really quick and just click on that request that was getting that 404. And I'm going to go to the headers tab. And if I come down to my response headers, you'll see that there is a response header set of server Istio envoy. So what that's telling me is that the request did in fact get into our cluster. It reached either the ingress or one of those envoy sidecars, and that set this header and set the request back as a response header. But since we see this, we know it's something internal to Kubernetes, Istio, or app code, and it's not something external like DNS. But since we've ruled that out, we can go ahead and look at some of our Istio setup and see what's going on. So I'm going to go back to my terminal. Let's just reset the window. So for the most part today, the tool I'm using for troubleshooting is the Istio CTL. If you've worked with Istio before, you've probably used it, whether it be to install or upgrade Istio. But beyond that, it also provides a lot of troubleshooting capabilities. One of those capabilities is called Analyze. So what Analyze does is it'll actually do a live analysis of all of your Istio configurations, whether that's for an entire namespace, a workload, or even static files. And it'll print out any validation issues it finds along the way. Personally, for me, this ends up covering about 90% of the issues I encounter while I'm troubleshooting Istio, and it's always my first line of defense. So I'd always highly recommend that you use this if you run into issues, just to make sure you're covering those bases. So anyways, we're just going to run this at the namespace level. So I'm going to go IstioCTL analyze -n welcome app, and that'll take a second to run. Okay, so you can see that we do have some issues here. Right now, we're just going to focus on these first two, which end up being the same problem. What this is telling us is that we have a virtual service named app ingress in our welcome app namespace that's referencing an Istio gateway that doesn't exist. It's referencing Istio ingress gateway in the Istio system namespace. So just for all clarity and making sure everyone understands kind of where we are in the flow, I'm going to go back to my slides. We're right here. So basically, the request is getting into our ingress gateway. But since that virtual service is registered with an ingress gateway that doesn't exist, it can't actually route the traffic to. So for us, this should be a pretty simple, quick fix. Let's take a look at all the gateways we have defined in our cluster. So I'm just going to do kget gateways -a. So we have two. For the intents of this demo, we're going to focus on the main gateway. That gateway is the default gateway that does get created by Big Bang, and that's the one that our virtual service should ultimately be using. So for a quick fix, I'm just going to modify my virtual service, edit VS in my welcome app namespace, app ingress. And like I said, if we come down to our spec in our gateway section, you can see that this is referencing that Istio ingress gateway. So I'm just going to quickly update this to main, save it. And you can see it was edited, and I'm just going to arrow up and analyze one more time. Okay, so you can see most of those issues have cleared up. We still have one left that we'll come back to, but let's go ahead and see what's going on with our application and see how it's performing now. So I'm going to do a hard refresh. So you can see we made a little bit further. We did make it to the UI, but unfortunately for us, we can't get to the back end. We're getting a 503. So in context of sort of where we're at in the application, we're here now. We made it through our virtual service. Our virtual service is successfully routing to our UI, but unfortunately, there's still some underlying issue that it can't get to the back end deployment. So I'm going to come back to my terminal, and let's take a look at that last remaining issue that's being displayed by Analyze. So what this is telling us is that we have a Kubernetes service named backend in our welcome app namespace. And in that service, a port is defined, 5,000, but that port is not adhering to Istio naming conventions. Naming standards within Istio are very important, especially in context of Kubernetes services. If you don't specify a name, Istio doesn't know what protocol to use, and it can cause a lot of other issues. So let's just go ahead and take a look at this service and see what's going on. So I'm going to edit that in my backend service, and I'm going to come to the bottom, and let's take a look at our port section. So you can see here that there's 3 fields listed: port, protocol, and target port, but there's no name field. So I'm just going to quickly come in here and add name HTTP. For me, I know this is HTTP traffic, and I know that's what this name needs to be. But Istio does support a lot of other protocols They're all very well documented, and a quick Google search should show you all those if you're curious. But since this is HTTP, I'm just going to name it HTTP and save it. You can see that it was edited, and I'm going to analyze one more time. Great, so we've gotten past all of our validation issues. Everything should be good from that side of things. Let's come back to our application and see what's going on. So I'm going to click OK and do one more refresh. So we made it a little bit further. Instead of that 503 we were seeing before, we're seeing a 403. Just in context again of where we're at, this is where we're at. Haven't made it much further. We're still stuck at that back-end deployment. And if I come back to the UI, so generally speaking, if I'm working with Istio and I see a 403 error, that's an HTTP forbidden error. Usually, my first assumption is that it's something related to Istio authentication and authorization, whether it be an authorization policy or something of the sort. One quick way I can mostly confirm that is checking, again, the JavaScript console. And I'm going to come down to that request that was throwing that 403. And instead of going to headers, I'm going to go to the response. And you can see that the response coming back from this is an RBAC access denied. Usually when you see that, it is something pertaining to Istio Auth, and I've pretty much confirmed that. So since we have confirmed that, let's go back to our terminal. So features are constantly getting added to IstioCTL. Some of those features are considered experimental, and even though they are experimental, they're still very powerful, especially in context of troubleshooting. One of those features is known as Auth check. So I'm going to clean up my terminal, and let's do IstioCTL exp for experimental Auth check, and I'm just going to output the help message. So what Auth check is doing, it's actually providing a comprehensive list of all the authorization policies that apply to either a specific deployment or pod, whether those auth policies are scoped at the mesh, namespace, or workload level. It's just a great way for seeing how Istio is managing authentication and security on that specific workflow. So I'm going to reset just to clean it up one more time. And let's go ahead and run that against our backend deployment and see what's going on. So IstioCTL, exp, auth check. This is in the welcome app namespace, and I'm going to do this against my backend deployment. So when I run that, you can see that we have one single authorization policy being applied to this specific backend, and that's our internal auth policy. Let's go ahead and take a look at that and see exactly what it's doing. Policy in the welcome app namespace, internal auth policy. So I'm going to come down to the spec. So this is a pretty straightforward auth policy. All this is saying is that workloads within the welcome app namespace are allowed to talk to other workloads within the same namespace, that welcome app namespace. So this is your inner namespace auth policy. But since this is a backend API and users' browsers need to hit it in order to grab that user data to display in their browser, this isn't quite exposed enough for the purposes of our application, and we're going to need to expose it a little bit more. So I'm going to get out of that. Now, fortunately for us, I do have an auth policy ready to go. And just to walk through what this auth policy is doing, again, it's scoped at the welcome app namespace level, but it's only going to apply to workloads that are labeled with app backend, which will apply to our backend workload exactly as we want. But for this one, it's going to allow traffic from the Istio system namespace. That is where our ingress controller is and the ingress point of our cluster is. That's where we want this to only be allowed, not to the world. This way, only basically a request from the browser can get to this workload instead of things from another namespace, for instance. And it's only going to allow HTTP GET requests, which for the purposes of this is plenty wide enough. So I'm going to go ahead and apply that. -F backend. So you can see that was created. Let's come back to my terminal and let's rerun that check command one more time. So you can see now that we have two authorization policies exactly as I wanted. The one thing I also like to check is just make sure that label selector is working and this isn't being applied to any workload that I don't want exposed to the world. So I'm just going to quickly run that against my Mongo deployment, which is our backend database. We would never want that actually exposed to the world. You can see exactly as expected, the only thing being applied to that is the internal auth policy. So that's exactly what we want. So let's come back to the browser and we'll do one more hard refresh. So the good news is we made it past all of our HTTP error responses. But if you didn't notice, we still aren't getting redirected to SSL. And the application still doesn't know who we are. So we're going to need to dig a little bit deeper into IstioCTL and take a look at the proxy configurations for our backend deployment. So if you didn't know, every sidecar proxy that gets deployed by Istio has this dynamically changing configuration that gets injected by an Istio component called Pilot. And inside of that configuration, it's basically telling the proxy and the mesh how to route traffic using pattern matching and defined protocols. I do want to give a quick overview of how our auth redirect flow works. For that, the easiest way is to pull up the slides. And let's go to the next slide, which is where we're at right now. For context, we're getting into our UI and our backend, but the user isn't getting authenticated. So what we have an Envoy filter called Auth service that's defined in our Istio system namespace, which is our Istio root namespace. When you define an Envoy filter into your Istio root namespace, it will apply globally to all workloads that both match the label selector on that Envoy filter and are also Istio injected. That Envoy filter sits on the default ingress port of the Envoy sidecar itself, which is 15006. So when a request comes into that sidecar, that request is going to actually percolate through all of the Envoy filters it has defined before it reaches your application. So for this specific filter, what it's doing, when the request comes into it, it takes that request and proxies it to an auth service deployment in the same cluster. If you don't know what auth service is, it's a great tool maintained by Tetrate, and that's managing our jot validation, our redirects to our centralized SSO, whether a token is expired or invalid or just doesn't exist. And the last thing it does, it will set the jot authentication header in the request before it passes that request to the application. That way the application can consume that header, parse it, and be able to identify a user. And that's exactly what our application is going to be doing today. But since we are not getting redirected, we need a way to check just to see if that filter is actually being applied to our sidecar. So fortunately with IstioCTL, we have a way to do that. So we're going to come back to my terminal, reset this, and I'm going to use the proxy config capability. And I'm going to do this, like I said, against the listener on ports 15006. Again, we're going to scope this for the welcome app namespace, and I'm going to run this against my backend deployment. I'm going to output it as JSON, and I'm going to pipe it to less just for readability. So this comes back with a pretty long JSON. This is basically the listener configurations on this specific port for this sidecar. For the sake of this demo, the only filters I really care about are the HTTP filters. I know that's where things are failing right now. So I'm just going to grep for it. So you can see here, this is an array of objects. Inside of this array, these are all the Envoy filters, top to bottom, that a request is going to percolate through before it gets passed on to your application. And what I would expect to see here with my external Auth policy is that listed here somewhere. But as I scroll down here, I don't see it anywhere. I don't see any reference to Auth service, which is one of the parameters of that Envoy filter. There's really no reference. And by the time I get down to the end of this array, it's clearly not there. So unfortunately, our Envoy filter isn't being appropriately applied to this workload. So let's go ahead and we'll exit out of this. Much like everything else in Kubernetes, Envoy filters use those label selectors. That's usually the first place I'm going to check. So let's just take a look at our labels on our deployments. And I'm going to do git deploy -n welcome app. Let's just show the labels. So you can see for our two externally facing deployments, backend and UI, we have this auth enabled label being attached to those. And that ultimately is what our Envoy filter should be referencing. So I'm going to go ahead and take a look at our Envoy filter. Sorry about that. -n. This is in the Istio system namespace, auth service. And if I come to the bottom here, you can see that instead of that, our workload selector is set up for auth none. Obviously, that's not going to work for us. I'm just going to quickly update this to enabled. So I just made a change to my mesh. Like I said, inside of every sidecar is this dynamically changing configuration. And as I made that change, Istio Pilot should take that change and push it to all of the sidecars. That way they know how to route traffic with this updated Envoy filter. But how can I be sure that Pilot successfully did that? So again, you can use IstioCTL, and it's very quick and very easy. So I'm going to do IstioCTL proxy status this time, and I'm going to do it at the namespace level. So when I run that, you can see that we're synced across the board. Pretty much every sidecar that is deployed within this namespace, that change that I just made was pushed to it, and it's all appropriately synced. And if I arrow up, and let's rerun my proxy config command one more time, let's look for HTTP filters. And I scroll down on this array this time, you'll see near the bottom now that I do have this new entry here for my external Auth Envoy filter, and this is referring to that auth service deployment running in this same cluster. exactly as I would expect. So if I come back to my browser, and I do usually have to do a quick close and reopen, bear with me 1 second. This is just for local caching issues. Let's navigate back to welcome.istiocon.xyz. You can see now I've been appropriately redirected back to our centralized SSL. And if I log in with my credentials, you can see that it's displaying the welcome message exactly as we wanted it to. So hopefully that demo shows some of the really powerful stuff you can do just by utilizing some of those capabilities of IstioCTL. But beyond that, it still provides a lot of other benefits, especially when it comes to the maintainability of your clusters. And beyond IstioCTL, there's a lot of other tools that you should be utilizing, both for troubleshooting and maintenance. It's just tough to squeeze those all into 40 minutes. But to talk a little bit more about those, I am going to kick it back over to Nick. So Nick, all yours.
Great. Yeah, amazing live demo that Adam just did there. But you're probably wondering, like, he only showed us how to use IstioCTL. And that's because a lot of the work that's been done in the community over the last year or two has really wrapped up into these awesome commands. And we've kind of laid out here the steps that you can take to really get some really effective debugging strategy into Istio. So like always start with that analyze, because you're probably going to catch 90% of those easy issues that you might have like misconfigured or fat fingered, for example. But if that didn't work, look at the experimental options. With every version of Istio, more and more experimental options are being added, and they might just solve the use case that you're trying to fix. But then if you really need to dig deeper, the easiest way to do that is to look at the proxy configuration of Envoy using the IstioCTL command. It allows you to filter down to your ports and applications so that you don't have to dig through thousands of lines of JSON. Proxy status is also really effective to make sure that your mesh is all up to date and everything is being received correctly. Then there's some other tools that you can definitely run in different states to check the maintainability, maintain your Istio clusters healthy by running upgrade with the dry run option to check to see if it's ready for it, Istio upgrade. Verify install checks that your Istio deployment is up and running correctly. And then I wanted to focus really on the last one here. This is a newer addition to IstioCTL called bug report. And what it does is it runs through some analyze, for example, and a couple other commands, and it gathers all of the Istio configuration and context of your cluster and bundles it into a zip file. And so it's a really effective way to share Istio, problems with Istio that you're trying to debug. We've been running it in the DoD. If they have problems, they run bug report. They can send me that zip file. I can look at pretty much everything I need to from an Istio standpoint within their cluster. It's also obviously really useful for submitting bugs to Istio as well. So when, from here on out, I would totally recommend that if you want someone else to help you with Istio debugging, give them the bug report. It's a really easy way to share your Istio problems. Some of the things we didn't talk about, we didn't have time to show, a lot of other amazing things have happened within the community in the last year. And that's in terms of monitoring. The Istio operator has become a lot more mature. And so these are things that you should absolutely be using and deploying, especially all the monitoring tools, Prometheus, Grafana, Tracing, Kiali. And so to really have an effective Istio deployment, you need these tools. And so you should really plan to put these in your environments because they give you a more broader picture of how Istio is operating. And so, really push to get those into your environment. Some of the awesome additions to the Istio operator, for example, is that they've recently added support for upgrading your ingress gateway separate from your Istio D deployment. And so it's made upgrading a lot easier from an Istio standpoint. Some other ways that you can use Istio in a much more effective manner is Tetrate is offering a platform called Get Istio, which is a distribution of Istio that is kind of on Rails. That makes it easier for that lifecycle management of Istio, easier to install, easier to operate, and easier to upgrade. And then it also offers a couple different flavors of Istio. FIPS compliance, for example. We're working with the DoD to get those hardened approved images into this distribution. And so definitely go check that out. It's open source, and we have a lot of weight behind it already. And there's also a community started to make Istio easier to adopt. Then if that's not working, go check out discuss.istio.io. There's a lot of great posts of people who've had problems with Istio and different types of troubleshooting that they've done. It's a really great forum that I frequent, and I do a lot of support for. So if your use case hopefully isn't that unique, and somebody else may have run into the same problem as you, and so you can discuss bugs that may have already been fixed, or submit new ones. But finally, if that hasn't really solved your debugging problems, you should absolutely get involved in the Istio community. Bring your problems to the Slack workspace and post them there. It's a really good way to get in touch with the developers and contributors of Istio. And then finally, if none of that else is working, it's probably a bug. You've probably found an Istio bug. Submit that to GitHub. Don't forget to run Istio CTL bug report. Yeah, and I think that's largely it. Go check out the Big Bang platform. You could go install it today and use those hardened approved images. Thank you very much.